All right, good morning. It's 8 o'clock, so we'll go ahead and get started. So this is week 6, and the class material for this week is about methods. Methods are an extremely important part of not just Java, but any kind of programming. What methods allow you to do? It allows you to take, say, a complex concept and break it down into smaller individual steps. The idea, or excuse me, the example I kind of like to talk about is, say, a car, right? So a car is a very complex piece of machinery, right? But I mean, is it really? If you kind of think about a car as a whole concept, you can kind of start breaking it down piece by piece. We'll use a simplified example. I won't talk about every single piece of a car, but just kind of general concepts. So you have this one entire entity that's a car. Well, you can break that down into, say, the engine, the body of the car, the steering system, the braking system, and the wheels. Yeah, I'm sure there are more than that. Let's just go with those 4 or 5 different pieces. So you have one car, but you break it down into those 4 or 5 different pieces. All right. So let's take one of those pieces. Let's look at the engine of a car. Okay. And you can consider the engine of a car as one complete piece, but it's not really one piece. An engine is made up of a bunch of smaller pieces, right? So you'll have your fuel injectors, you'll have your cylinders, you'll have your alternator, you'll have the battery, you'll have fuses, you'll have hoses, you'll have the radiator, right? All these different sub pieces of a car. Okay. And we'll see where we're getting with this in a second. Okay, so let's take one of those pieces and break it down further. Let's say we look at the alternator of the car. Okay. So, and is an alternator just one piece itself? No, an alternator is made up of a bunch of sub pieces itself. It's made up of, say, like the pulley wheel. It's made up of the magnets inside of it. It's made up of the coiled wiring inside of it. It's made up of the metal housing that holds all the pieces together, right? Okay. So let's take one of those pieces and break it down further, right? So I don't know, the metal coils inside of it, right? So that's one of the pieces of an alternator. So we can look at that. Okay, well, the metal coils, well, it's made up of copper wire. It's made up of some kind of spindle. I probably can't go much further than that. It's about how far I can go down this chain of car things we're talking about. But I think you can kind of see the point to where you can have one really complex object, which is the whole car, and you can break it out into individual pieces. And then you take that one sub piece and you can break it out into smaller individual pieces. And then you could take that sub piece and break it out into individual sub pieces below that. You can have many, many, many layers of breaking this one complex object down into smaller and smaller, simpler pieces. And at the very bottom of this whole breaking things down, you should have a relatively simple, for the car, a really simple physical piece that you will go and manufacture this simple piece. You manufacture all of the additional extremely simple pieces. And then once you have all the extremely simple pieces manufactured, you kind of start putting them together to build up those larger and more complicated pieces of the car. Really, a computer program isn't that much different. You'll have, let's say you have one complicated program, let's say Google Chrome, well, any generic web browser, right? A web browser is an extremely complicated piece of software underneath it. It probably has millions of lines of computer code running that browser program, right? But the people, they didn't just sit down and just program it all at once in one large main function. No, it's not programmed in one function. They take the concept of a browser and they break it down into simpler pieces. Well, how can a browser be broken down? Well, you have like the address bar, right? So you can break a browser down into, say, the address bar, all the back, forward, reload buttons, all that stuff. You can break it down into the bookmarks bar. You can break it down into, the actual content that it displays to you. Okay, so you could take a browser and break it down into, say those 6 or 7 pieces. Well, then you take one of those. Let's say we take the bookmarks bar. Okay, you take the bookmarks bar and break it down into, well, each individual bookmark and maybe a button to add something to your bookmark bar, maybe a button to remove something from the bookmark bar. Okay, well, now you take one of those individual things. Let's say one of the buttons for one bookmark that you created. Well, you can break that down into smaller pieces. You can break it down into, say, the little icon that it shows. You can break it down into what web link it actually goes to. You can break it down into what actually happens behind the scenes when I click that button. All right, let's break those down into a smaller piece. Let's say what happens when I click it. Okay, so let's look at that. Whenever I click it, I probably want to change the address in my address bar. I want to download some files off the internet, and I want to display that content in the main content area of my web browser. So we took that one concept, clicking on the bookmark, and we broke it down into 3 separate steps, right? For the example, I'm not going to go below that level. There's a lot more steps below that level. But so, I took the concept of clicking on the button and 3 steps happen. 1, I change the address in the bookmark bar. 2, I download whatever the resource is off the internet. And 3, I display that content in the main area of my web browser. So those are 3 smaller steps that have to happen for this larger concept of a web browser. So we just kind of broke it down like that. And so you can think of those lowest level things that are happening as their each individual own method. So this concept of making methods is taking a complex subject, breaking it down into smaller pieces. Each smaller piece will have its own method, and we will discuss how to make our own methods. But we'll break them down to their each own individual method. And once we have those basic level methods created, we will combine them back together to make the larger concept. I think the text actually gives a really good example of what they talk about a black box. A method should be a black box. And what we mean by black box is you don't really concern yourself about what the content of it is. Meaning, if you have a method, you're not really concerned about what happens inside of the method. You treat it like a black box. You don't care what happens inside of it. You only care about what you put into it and what you get out of it. And the really good example they use for this in our text is they talk about a television set. So with a television set, as the average user of a television set, you don't know how a TV works. You don't know all of the electronics inside the TV. You don't know about everything that goes into a TV that makes it work. You just know about the inputs that you give a TV, which are, whatever you type in on your remote control, plug the power cord into the wall. Those are the inputs you give to the TV. And the TV gives you back outputs. right? It gives you a picture on the screen. And as the user, you know that you can push some buttons on the remote control and you can change what the picture displayed on the TV is. That's an example of a black box because you understand the input you're giving it. You understand you're pushing buttons on your remote control. You understand the output it's giving you, the picture on the screen, but you really have no idea internally how that TV works. And on top of that, it doesn't even matter to you internally how that TV works. The TV can do whatever it wants to do as long as it takes the input that you give it and it gives you back the output that you expect. So for our TVs, you know, whenever TVs were invented back in the 30s or something like that, you know, from the 1930s until probably around the 80s or 90s or so, I don't know the exact dates. You know, TVs used like vacuum tubes. That was the technology, right? The inside of TVs used vacuum tubes as part of how they worked and how they displayed stuff to you. The average user didn't care about that. They didn't care to use vacuum tubes. Then, you know, somewhere around the late 90s, early 2000s or so, we weren't using the vacuum tubes. We were using, you know, transistors and microcontrollers, and you know, this when we started getting HD TVs and all this stuff, and all the TVs became much flatter and instead of the, you know, the big boxes. So someone that used a TV that went from vacuum tubes to the transistors, did that person care internally how that TV worked? The answer is no. They didn't care if it used transistors or, excuse me, if you use vacuum tubes or transistors. The input to the TV remained the same. You have some kind of control device, and the output remained the same. You have some kind of display screen. Okay. And so you as a TV user, you shouldn't care if it uses transistors or if it uses some kind of magic inside that black box that's a TV. How the TV works internally is irrelevant. The only thing that matters is what the inputs are and what the outputs are. That's what it means by black box. And whenever you create your functions, you should also consider them black boxes, meaning the input and the output needs to remain consistent. Internally, how it works is really irrelevant. If you are the one making the function, then yes, you do need to know internally how it works because you have to create that. For our TV example, there had to be engineers that did understand the internals of a TV and had to create the internals of the TV. But from the point of view of someone using the TV, they don't care about that. It's the same way with methods. The users of the method don't care about the internals. They just care about the input and the output. But if you are the engineer making the method, you do have to understand the internals of the method because you're the one that has to make it. So we'll talk about a few examples of methods that we are going to use, but that somebody else created. And we'll look at those from the black box perspective. Somebody else created the method. So internally, we don't care how that method works. We just care about what the inputs to the method are and what the outputs are. So we'll talk about methods from that perspective, and then we'll talk about methods from the perspective that we are the ones creating them. Okay. So let's get started. So methods that someone else wrote. Believe it or not, you've been using those the entire course so far. You have already been the user of methods. You have not written any methods yourself yet, but you have certainly been using methods that somebody else created. The most prevalent one, system.out.println. Hello. Oh, there we go. Hello. This is a method. This system.out.println. This is a method that someone else wrote. and we are the users of the method. So let's look at this for a method. So a method has the general form of, I'm going to write it as a comment here, but you will list your modifiers, and we'll talk about what each of these are. Modifiers, the return type, the name, and the parameters. That's what a method will look like whenever you create it. So for the modifiers, whenever we use the method, we're not going to see the modifiers, so don't worry about that. The return type, we will talk about this when we create our own methods here shortly. The return type is what the method gives back to you. And there are several for the return type. A return type can be either a void, an int, a float, a double, a string. It can be stuff like that. And we'll see that really good examples of that whenever we make our own. So that's the return type. Then we have the name of the method, and that's what we have here. We have the name. This is the name of the method that we are going to use, this println method. And then inside here is the parameters. This is the input that we are giving to the method. Okay, so let's think about this for a second. You know, of course, if we run this, what's it going to do? It just prints out hello, right? That's what that does. When we call this method, we already know it's just going to print out whatever's right here, right? And so that's all there is to that method. So, like I said, we treat it as a black box. This is the name of the black box, this println method. This is the inputs we give to that black box. And what are the outputs in this case? For our TV example, the outputs was the picture it displays on your screen. Well, the output from this method is, it just prints out whatever the input was. So we are using this method to print out whatever the input is we gave it. So that's one method we have been using. And as I said, we treat it as a black box because this println method, how does it actually work? How does it actually print something on your screen? How does that happen? And the answer is we don't know. The answer is also we don't really care what goes on behind the scenes to allow that to be printed on the screen. We don't need to know it. The only things we need to know is this is the name of it. Inside here is the input we give the method. And if we treat it as a black box, the only thing we care about is what is the output. And this is the output of that method. The hello. Other ones we've been using, say when we create a scanner, it's a new scanner from system.in. So say hello, we'll say input number, right? So that's still the same method that we're using. What's another one we use is the scanner dot, scanner dot next int, right? Oops. Equals. There we go. This is another method, the scanner dot next int. The next int does a lot of work behind the scenes, but at the end of the day, it gives us back the integer that the user typed in at the keyboard. And since it gives back to us that integer, you know, we just make this variable equal to whatever they typed in. But the point of this example is the scanner dot next int. when we look at kind of this thing right here, modifiers return type name. So the next int, we know its return type is an int. And I can infer that because I'm saying this int variable is equal to that method. That means this method has to return an int. It means it, whenever we call the method, it gives us back an integer. If I had a float here, other number, dot next float, that would mean this method gives us back a floating point number. And we can see that if I hover over it, my IDE is pretty smart. If I hover over the method, it'll tell me all about it. And as you can see, the first line on there, it says public float next float, right? So public is the modifier, and we'll talk about those whenever we write our own methods. The float is the return type. So it's telling us that it will give us a float type variable in return. And then it tells us the name of it is next float. And then it gives a whole long description of everything it does. But again, the point is how that internally works. That's the next float. There's the next int one. There's the print ln one. You know, the whole point is we're not worried internally how it works. We just worry about the input to it and the output it gives us. Okay, so we kind of call them built in a little bit, meaning these methods already exist in Java for you to use. But when I say they're built in, it's not inherently part of the Java programming language. It's just kind of already bundled in there with it. And what I mean by that is somebody else had to create this method. Someone else wrote the code that makes this method work. All right, some other human being they created this next float method so that it does all the stuff it needs to do and then gives back to you a result. You can think of them as the engineer for the method. It's equivalent to the engineer that built the inside of the TV set. All right, there was an engineer that built the inside of this next float method, but we as the user don't care about the insides. We just care about the input and the output. But ultimately, someone did have to create those. They're just kind of bundled in with Java by default so that they already exist there for you to use. But rest assured, some other person did have to sit down at a keyboard and create all the internal code of this next float so that it works properly whenever you go to use it. So let's switch from this black box concept of using someone else's methods, because that's what this is. We're using someone else's code. Let's switch hats a little bit and let us be that engineer. Let us be the one that creates the internals of a code. We're going to make our own methods. And let's see how that works. You know, that stuff. So as I said here, this is kind of what a method looks like. Code of the method. There. So we'll have the modifiers. It's actually just modifier one. The return type, the name, and the parameters. So for modifiers, there are 3, but right now we're only going to focus on 2 of them. One of them is for higher level classes, so I'll mention it so you know it exists, but it's not really applicable to this level of the course. The first one is what we call public. We also have protected, and we have private. Those are modifiers. And what do each one of those do? Let's make a couple of examples of different methods. It'll be easier if we have an example to refer to. It'll be easier to explain what each one is. Oops. All right. So we have this concept of public, protected, and private. Okay. So protected is the one that we're not really going to talk about. It's for higher level concepts than what this course goes over. Just know that it's kind of a middle ground between public and private, which we will discuss here shortly. So you can understand there is a modifier that's protected, but it's a little bit beyond the scope of this class. So we're not going to worry about it right now. Only ones you need to worry about are public and private. So what public and private boil down to is inside the current code block, right? If it's public, then this method can be accessed outside of the current code block. And I'll show you what a code block is here in a second. If it's private, it means that it cannot be accessed outside of the current code block. So what is a code block? A code block is basically what your curly braces are. So we have our main, which our main is actually a method. We have our main here. Inside the curly braces is a code block. If I can spell it right. Curly braces is a code block. So this is a code block between that brace and that brace. Inside of here, you know, if we have an if statement, this is another code block between these two curly braces. All right. They can be nested inside of each other. That's fine. Even inside of here, you can have another level. So we have this code block right here. This is one code block between these two curly braces. It is nested inside of this code block. Okay. That is further nested inside of this code block, this main method code block. And this main method is further inside of this class code block, which starts right here with that curly brace and ends down here with this curly brace. All of this stuff is inside of this class code block. So that's what a code block is. It just designates code inside of these curly braces. So whenever I talk about this public and private, the public means it can be accessed outside of the code block. So if we look this method here that says public, what code block is it inside of? It's inside of this one right here, right? This class code block. It's inside of there. So what the public means is that this method, it can be accessed outside of this class. So if we had another class here, whatever, oh no, I just typed in some random letters. Don't worry about the red squiggly right yet. But it means that we can use this method, this A method, even though it exists inside of a different code block. Because I say it's public. So public means it can be accessed outside of that code block. Conversely, private means it cannot. So here we could use main.a. And I say main.a because it's inside of this main class and the name of it is A. And since it's public, it means we can use it. And then here we cannot use main.b And the reason for that is inside of this main code block. Oh, I'm sorry, it's C, not B. So still C. Inside of there, there is a C, but since it's marked private, it means I cannot use it outside of this main class code block. So that's why we can use the A, but we cannot use the C, because one is public and one is private. And the reason why you would want to use either public or private, it just depends on you, the programmer, the engineer that makes this functionality. Do you want someone outside of the code block to be able to use it? It really depends on what you're trying to engineer it for. The same thing with the private. If you do not want someone outside of this code block to be able to access to it, if we kind of talk about our TV concept, public, if this code block represented a TV, right? If we had a function here to change the channel, you would probably want that to be public because you want the user to be able to change the channel. So that would be a good reason to make it public. For private, increase electricity, if I could spell, to transistor XYZ, whatever. This method increases the electricity to a specific transistor. Do you want the outside user of the TV to be able to do that? And the answer is no. Someone who is using a TV, they don't need to be able to do this. They don't need to be able to control the electricity to a single transistor. So that's why it's private, so that only the TV itself could use that method. But you want anyone to be able to change the channel of the TV. So the user sitting on their couch can change the channel, but the user on their couch can't increase the electricity to one specific transistor. That just doesn't make sense. So that's the difference between the public and the private, and kind of an example of where you would use one and where you would use the other. So public is if you want someone outside of that code block, outside of that system, to be able to use it. And private is if you do not want someone outside of that system to be able to use it. All right. So let's continue on. Now we talked about public and private. So right now we'll keep our method private. Let me erase these code blocks. All right. So then you have the return type. Bring my scanner back. We talked about the return types when we talked about the scanner, right? System.in. Scanner.next. Yep. There we go. And then let's do the float one again real fast. Num float scanner next float. There we go. So for these methods, the scanner.int, if you kind of hover over it, it tells us it's a public method, and int is the return type. That means it gives us an integer as a value that the method gives back to us. If we look at this next float, it tells us it's also public, and the return type is a float. That means whatever internal work it does, it gives us a float back as the answer. And same thing, we can have a string one, right? Scanner, and it's just next. We look at the scanner.next, it tells us it's public, and it returns to us a string. So the return type is we give the method some specific input. The method does whatever internal work it wants to do, and the return type is what it gives back to us as a result. What is the answer that it came up with, depending on whatever it was trying to do? So for the next int, it gives us back an integer. For the next float, it gives us back a float. And for just the scanner.next, it gives us back a string. And you already know that from the assignments you've already done. And so when we're making our own, we need to tell it what's the return type. Like I said, you can have void. So you can have void, int, float, double, string. Those are all the basic return types that you can have right now. They can get more complicated than that as you get into later classes, not this course, but higher level courses. You can see you can get different return types, but for our basic level course, these are the different return types. Now the int, the float, the double, and the string, those should all make sense to you. You've been dealing with those a lot. But what is the void? The void just means there is no return. And actually, you've been using one of those. When we look at system println, is something. When we look at it, it tells us the type is public and the modifier is public and the return type is void. What void means is that it does not return anything. It does not give you anything back. So what it means, I can't say string S1 equals that. I get the red squiggly lines because something's wrong. If I hover over it, it tells me what the problem is. The required type is string and the provided is void. That may sound a little cryptic. You can get used to looking at these things the more experience you have with it. But it's telling us that we want a string, but it's giving us a void, meaning it's not returning anything to us. So when we put void, it means we cannot make a variable equal to it, because what the method returns, what it gives back to us, is nothing. That's what the void means. It does not return anything. Now, it does actually do something, right? It does actually print to your screen. If we delete all this stuff, whenever we run it, it's going to ask me for this integer, float, and next. Integer, float, and next. That's fine. Then, whenever it gets there, it does something. It prints this to the screen, but it does not return anything to us. And because it returns void, which means nothing, I cannot make a variable equal to it. Not a string, not an integer, not a float. Because it returns void, it returns nothing. It does not return a float. So that's why whenever we call the method that has void as a return type, we just have the method name itself and whatever parameters we want to give it. Conversely, whenever we do next int, it does return something. It does return an integer. So we can say the variable is equal to whatever it returns. All right, let's go on with our example. So that's the return type. So if I put an integer here, it means it's going to give back to us an integer answer. And then here we have the name. This is a long name. The naming convention is the same that applies to variables. And what I mean by that is the name can be anything. The name can be this, whatever that is. It doesn't make sense to name something, a bunch of random characters, because if I use this function, if that's the name of it, for one, it's going to be really hard to type that in. And for two, this is not a good description of what it actually does. you need to name things that kind of give you an indication of what it does. If we look at the next int and next float, that gives us a pretty good indication of what it does. Just looking at the name is a good indication. It's going to, give me back some integer. It's going to get the next integer. This is an indication it's going to get the next float. Although this one, it doesn't say next string yet. So, maybe this would be a little bit better if it was named next string. Whoever made it didn't see fit to do that. So it's just next. But at least for these two, they're pretty descriptive of what they do. So the same thing with a method name, it needs to be pretty descriptive of what it does. For our example here, we're going to make a function that adds two numbers together and gives you the answer back. All right. So what would be a good name for that method? Well, a good name would be maybe add two numbers. All right. That is a name that is a pretty good indication of what the method does. Okay. Now inside of here, we need to do the actual work. We need to add the two numbers together. So let's have a num1, let's say it just equals 5, and a num2 is equal to 10, right? So this method is supposed to add two numbers together. Well, there's two numbers. Let's add them together. And now we said we are going to return an integer. An integer is going to be the answer, right? And we even said the name of the method is add two numbers. So we have taken one number, we have taken two numbers, we have added them together. Now we need to return the answer. We said we are going to return an int, so we need to return an integer. And the way you do that in Java is with the word return. And then you put what it is you want to return. For us, we are going to return the sum. There is nothing stopping us from saying return num1. There's nothing that stops us from doing that. But this isn't really doing what we said it's going to do. We said we were going to add two numbers, but if we return the num1, that is not the two numbers added together, right? So the answer, whatever we whatever we return, it needs to be what should be expected that the function, that the method does. So we want to return the sum because that is the two numbers added together. We said we were going to add two numbers. We can put a comment right here that this method adds two numbers together and returns the sum. Maybe we put a comment right there that describes it. And so there we go. We have the two numbers, we add them together and we return the sum. So now how do we use this? We want to add two numbers together. Well, just like we did with the next integer and the next float and the scanner.next, we just have to use it by its name. So whenever we did the next int for a scanner, we had int, the variable name is equal to that method. Okay, let's see if we can do the same thing. We'll have int, the number is equal to static. Should have talked about static before. Without going too deep into it, just know for our basic level class, you need the static here. It's another one of the modifiers, just like private. Just for this course, just use static there. I can talk about it more advanced later if you want to know exactly why. But just know you need to use static there for this level of course. All right, so back to our example. I'm sorry Failed to mention that earlier. All right, so for example, we have int numbers equal to our method name, which is add two numbers. And then at the end, let's just print out what that number is. All right. So what's going to happen here? We're still making a scanner. I'm not using it right now. We will use it in a minute. Then we're going to say this int number, this variable number, is going to be equal to whatever this method returns. So whenever the program gets here, it's going to say, oh, you want to use this add numbers method. Well, this add numbers method is right here. So it's going to start executing this code. It's going to have the first number, it's going to have the second number, it's going to add them together, and then it's going to return the sum. When it returns the sum, the program comes back up here and it says, okay, I have this sum and this variable is equal to that sum. So the number is equal to whatever this returns. Since it returned the sum, it's equal to whatever the sum was, and then we're just going to print it out. Let's run that. As you see, it prints out 15. And that is correct. Because it prints out number. And what is number? Number is equal to whatever the method is. This method, it returns an integer. It takes this number and that number, adds them together, and returns it. So 10 plus 5, it is 15. So it returns 15. So the variable is equal to 15. And then it prints out the 15. You know, if we change this to something else, say 55, we run it. There we go. We get 65. Okay. So this isn't really terribly useful, right, for adding two numbers. Maybe we want to add any two numbers together. We don't want it to always be 55 and 10. So if we compile this program and we give it to a user, it's always going to give us the same answer, right? Because this number is always 55, this number is always 10. Well, let's change it up a little bit, and we want to be able to add any two numbers together. We want to give the method two numbers, and we want the method to add them together and then give us the answer in return. So that's where we have, you know, in our example of what a method is, this is where we have the parameters. If we look back at our scanner, instead of add two numbers, we do our scanner dot, actually the scanner, I'll get an example. When we look at our system.out.println, this is the parameter. What is inside of these braces here? What is inside of those are the parameters to the method. This is the input that we're giving the method. And even if we hover over the method, it tells us, again, the modifier is public, the return type is void, the name of it is println. Don't worry too much about that at nullable. That's just some extra stuff my IDE does. Don't worry about that. The important part is that string X. That string X is telling you what are the inputs to the method, what are the parameters to the method. This is showing us that this method, it takes one input parameter and it is a string. The X is just a name it gives that parameter. For the println, the name of it really doesn't matter to us. When we make our own method, the name of the parameter will matter. But since this the system out println, you know, it's a black box, it's a method someone else wrote, the name of the parameter isn't important, but the type of it is that it is a string. So that's why right here we are giving it a string. That's the parameter type. And what println does, of course, it takes this input parameter and it just prints it on your screen, right? So when we run this, whenever we call this method, we gave it this input, and the method just, it takes this input, it takes this parameter and just prints it to your screen. So that's what it does with the input parameter. So for our method, let's give it some input parameters. Let's go back. Let's do the add two numbers. So instead of no parameters, which you can see here in between these parentheses, I have nothing. That means there's no parameters. Well, inside of there, let's give it two numbers to add together. Let's say we want to add a 5 and a 6 together. We want our method to add those two numbers together. You know, it's a red squiggly line right now. And the reason for that is when we actually look at our method, we have to tell it what parameters that we accept. Right here, when we're creating our method, inside the parentheses, we don't have anything. It's blank, it's empty. That means our method, it does not take any parameters. Well, let's change that. Let's say, since we are the engineers for this method, we can do whatever we want. Let's say whenever somebody uses our method, we want them to give us two integers. We want them to give us integer A and integer B. So now, since we are the engineer making the method, we are saying we want two parameters. We want two inputs. The first input is going to be an integer, and I'm going to name it A. The second input is an integer, and I'm going to name it B. You're not limited to two. You can have almost an infinite number of input parameters if you want. You can really keep going forever as long as you want to type. But since we're the engineer for this method, we just want two. We want integer A and integer B. Okay? And so now when we call this method, I don't have the red squiggly line anymore. If I change my method to say just have one input, here I'm saying I just want one integer as a parameter. It's giving us the squiggly line again because we are trying to give it two parameters, but it only wants one. And if I hover over it, it kind of tells me, it gives me a description. It may look a little complicated, but the more experience you get with it, the better you'll understand it. But it basically says that the method only wants one integer, and I'm trying to give it two integers. So that just doesn't work. All right. So let's go back to having two integers as the input. So now inside of here, instead of say adding 55 and 10 together, let's add, A and B as the sum. So now what have I done here? I still have the same method name, add the numbers, but now I'm saying, if you want to use my method, you need to give me two integers, an integer A and an integer B. Inside of here, I'm going to add those two integers together, and then I'm going to return to you what the sum of those integers are. So up here, when we use it, we use it by giving the name of the method, and then inside of here, we give the parameters. This is the input. So what's happening here is really key. So whenever I say 5 here, this 5 will correspond to this first parameter. This 6 will correspond to this second parameter. So down here inside the method, A will be equal to whatever the input you gave it. So since you gave it a 5 as the first parameter, this A is equal to 5. This A is equal to 5. Since you gave it 6 as the second parameter, this B is equal to 6. This B is equal to 6. So now you are going to take the 5 plus the 6, and you're going to return the answer. Let's run it. And there you go. You get the answer is 11. Is that right? You know, this is where you would have a test table to make sure it's correct. Is that right? So I used add two numbers. I gave it a 5 and a 6. I'm expecting that it adds the two numbers together and returns to me the answer. So, you know, the expected output is 11 because 6 plus 5 is 11. I know that. I did that with the calculator. And so inside of here, the A is equal to the first parameter. The B is equal to the second parameter. I add them together, I return it, and it does indeed give me the right answer. So right now, every time, this is going to give me 11, right? So if I do this twice, or let's say 3 times, do it 3 times, it's going to give me 11 every time, right? 11. I could change these, say 6, 7. You know, what should it give me? It should give me 11, 12, and 13, right? Let's add that together. There we go. It does indeed give me 11, 12, and 13. That's a little bit better than whenever I had the numbers put in here. That was a little bit better, you know, when I had num1 is equal to whatever, num2 is equal to something else. It's a little bit better than that because instead of having the numbers here, I still have them hard-coded here, right? This is still going to give me 11 every single time. This is still going to give me 12 every single time, right? So it's a slight improvement. Let's get one better improvement. Let's ask the user to give me the numbers they want to type, they want to add. So we'll say num1 is equal to scanner.nextInt. Num2 is equal to scanner.nextInt. Let's tell them what we want them to do. Enter 2 numbers, right? Delete all this stuff. And then let's add those numbers together. The sum will be equal to the num1, add 2 numbers num1 and num2. And then we'll print out the answer. The sum is plus the sum. There we go. So here, this is all stuff you've seen before right here, right? Is we're going to tell the user to put in 2 numbers. We're going to get the first number they put in. We're going to get the second number they put in. And now we're going to use our method to add those numbers together. This method will take num1 and num2 as input parameters. You know, just a minute ago, we had like 5 and 6, and that works. That's fine. That 5 is integer A. This 6 is integer B. But we don't have to use actual numbers. We can use variables here as well. And so when we use our method like this, what is num1? Well, num1 is whatever the user typed in. Num2 is whatever the user typed in. So these numbers here are going to be whatever the user typed in. So if the user typed in, let's say 1 and 2, then num1 is 1. Num2 will be 2. So here I'm saying 1 and 2. When I come down here, A will be equal to the 1, B will be equal to the 2, and then I want to add them together. So this is much more powerful because it allows the user to determine what numbers they want. See, I did 3 and 5, and the sum is 8. And that's correct. If we run it again with completely different numbers, 44 and 55, the sum is 99. And that's absolutely correct, right? And actually, what we've created here, we've created a very basic calculator, haven't we? With this method being one small part of the calculator. That's actually a really good example. Let's expand it a little bit. So let's also have a multiply method. Multiply two numbers. Oops. It'll return an integer. So it's going to be private. Like I said, static. Don't worry too much about it. Just use it. It's for higher level classes. The integer is the return type. Multiply two numbers is the name of the method. Inside of here, we need to give it the parameters. We wanted to multiply A and B. So let's do that. A times B. And then we will return, let's just say it's C. So C is equal to A times B, and we're going to return C. So now we have multiply two numbers. So let's say instead of add, we're going to multiply them, right? So now if we run this, enter two numbers, say 3 and 4. I know it says the sum is 12 because, you know, that's what we have right there. Let's just say the answer is 12, is whatever. So if we run this again, put in different numbers, 33 and 11, the answer is 363. So if we want to make this more calculator-like, we say, you know, enter two numbers and then enter add or mult to add or multiply. You know, this is really kind of building up on concepts you've seen in the course so far. So say string S is equal to system dot, excuse me, not system, sorry, the scanner dot next. And so if the S is equal to, in our case, if they type in add, I'm not going to talk too much about this stuff. You've already done this stuff. Else if S dot equals, ignore case, mult, then we're going to do this. So now what we can have, and then we'll have the answer. Starts off being 0. Have this answer at the top. Where you place these is kind of up to style. All right, so what we have so far, we're making a scanner. We're just going to have this variable called answer. We're going to print out, enter two numbers. We're going to let the user type in two numbers. All this, you've already been doing this stuff. We're going to print out, enter, add, or mult. And then we get that if they're adding a mult. If they type in add, what do we want to do? Let's add the two numbers together. That answer is going to be the add two numbers. And we're going to add num1 and num2. If they type in multiply, the answer will be the multiply two numbers. Num1, num2. And then there we'll just print out the answer. Let's run it. So far we made a very basic calculation. Enter two numbers, say 2 and 3, add or multiply. We want to add them, and there the answer is 5. All right, let's run it again. Add two numbers, 4 and 6. Now we want to multiply. The answer is 24. And that's right. That's kind of a very basic calculator. And just like with the car example earlier, or like the TV example earlier, You have a very complex object and you break it down into smaller individual pieces, smaller steps, and you make each of those smaller steps as a method. It's kind of what we've done here. If we can imagine that this program is a calculator, the actual add and multiply, we broke it down into, we took the calculator and we broke it down into smaller steps. Two of the smaller steps are to add numbers and multiply numbers. And we broke those down into individual methods. Let's do one more example of taking this calculator and breaking it down into smaller steps. Let's say we have a private static int get a number. All right. Actually, that's not a very good example. We'll just keep it with those examples. The one more example we could do is, if we want to do subtraction, subtract two numbers. We want to subtract A and B. If I can spell it right. And then we could have int C is A minus B, and then we can return the C. So the same thing here, we can have the add, multiply, or we can have, say, sub, and that will subtract two numbers. So we'll tell them enter add or mult or sub. Now we can run that. Enter two numbers, 4 and 7, and we want to subtract them this time, and there the answer is -3. So this is us using our own methods. We created these methods, and this is how we're using them. We use it by the name of the method, and then we give it the input. We have to make sure that the input we give it matches what it expects. It's expecting you to give it 2 integers. So we have to make sure that we give it 2 integers. And then it returns to us an integer. We know that because if we look at the subtract, this is the return type. It returns an integer. If we look at the code itself, we can see C is an integer and it returns C. So that's why we can have this answer, which is an integer. This answer is equal to whatever it returns. Now you may be wondering, okay, this is simple. Why didn't we just put num1 minus num2? Why didn't we just put that? That seems a whole lot easier. And for this extremely simple example, sure. But the example isn't, we're not trying to show this complexity. We're just trying to show how to make your own method and how to use your own method. Let's say it was something significantly more complicated. Let's say we made a method static. Let's say it returns a string. Okay. And let's say we want it to go to a website and download the message of the day. Some websites have a message of the day. Each day you go to a website and it gives you some new message or some weather. Let's say you go to a website and it shows you what the weather is, right? And it just says it's going to be sunny today, it's going to be cloudy today, it's going to be rainy today, whatever the case is. But it just downloads that information over the internet, right? So let's make a method that does that, or we're going to fake it a little bit. So the name of the method is just going to be get weather, right? And it's just going to return a string to us. Okay. So let's forget about all this adding, multiplying, and subtracting. Let's simple it down. Let's get rid of all this add, subtracting, and all this stuff. Let's scanner. So instead, we just want to get the weather string. The weather is going to be equal to this get weather method. And then we're going to display it to the user for ln weather, right? So here's where all the complexity is. So it could be as simple as it's going to be sunny today, right? So we're saying this method, it returns a string, and we are just returning this string, right? So if we run this, it's just going to say it's going to be sunny today. If we run it again, it's still going to say it's going to be sunny today. If we run it again, it's going to be sunny today, right? And that's because the complexity in there is very simple. There is no complexity. It just returns the same thing every time. But you can imagine, and we're not going to do it. I'm not going to make a full-fledged network program right here, right now. But you can imagine we do some steps like connect to website weather.com, download the web page into a string, search that string for the word weather, parse out what the weather today will be, and then we're going to return what the weather of the day will be. That's something significantly more complicated, right? So we're no longer just returning, X, Y, Z, whatever. We're not doing that anymore, not just returning that simple string. We have to do all of this complex work. We have to connect to a website. We have to download the web page into a string. We have to search that string for the word weather. Then we have to parse out what the weather of the day will be. And then we want to return that string that represents the weather of the day. So this method just got significantly more complicated, right? But from the outside user, they don't need to know any of that complicated stuff that goes on. So if this were a method that somebody else created, you don't care about the internal engineering of that method. But because it is our own method, then we do have to worry about that. We do have to write all that stuff. And like I said, I'm not going to write this in front of you. It would take me a few minutes to find a website that lets you get this information. I don't want to waste everybody's time. But just know that you can make this significantly more complicated. And maybe instead of downloading it from a website, maybe you have a digital thermometer connected to your computer. So let's say you have a digital thermometer connected to your computer, or a digital thermometer connected to your computer. You will be like, get the temperature from the digital thermometer connected to your computer. And then, maybe if temp is greater than 80, then we want to return, it's a nice day. If temp is less than, say, 50, return, it's cold. Some stuff like that. So you can see the internal engineering of the program completely changed. But at the end of the day, we want to return in whatever the weather is going to be, right? Whatever you figure out the weather is, that's what you return there. So we went from a simple example of just saying the weather is nice every time. The next example was we connected to a website that told us what the weather was going to be. And for the third example here, let's say we have a digital thermometer connected to our computer, and we do some kind of complex programming there to connect to the digital thermometer and then read what the temperature is. And then depending on the temperature, we do different things. All of those are just different complexities there that you as the engineer you as the creator of that method, you need to understand how that works and you need to make that work happen. But from the outside user, they don't care how you got it. That's kind of that black box concept. So that's all there is to methods. Is when you make a method, you have its modifiers, either public or private. For really all of the examples that we're going to do for this class, at least for this week, they can be private. For the static, again, don't worry too much about that. It's beyond the scope, especially for this week. Just know that you need to use the static here. This string is the return type. Remember, we have void, meaning it does not return anything. That does not mean it doesn't do any work. It just means it doesn't return anything to your code. And then, of course, we have the usual suspects of an integer, a float, a double, and a string. It can be any of those things, right? For our other example, we have the return type of an integer because it multiplied numbers together. Here, for the get weather, we're going to have a return type of string because we want to tell it what the weather is going to be today. And then here for our method is the name of the method. The name can be anything you want it to be within reason. It has to match the same naming restrictions as a variable, meaning, it can be uppercase and lowercase letters. It can be numbers. It cannot start with a number, but it can have numbers in it. And it cannot have any special characters. So really any combination of letters and numbers, as long as it does not start with a number, that's the naming restrictions. But you want to name it something that gives it some kind of indication of what it does. Inside of these parentheses, you have what its parameters are. If we look back at our add, it returns an integer. We're just going to call it add int A, int B, A plus B. Oops. These are our parameters. The first parameter is an integer, and the name of it is A. The second parameter is an integer, and the name of it is B. And the return type is an integer, so we're just going to return this integer plus this integer. All right, that's all there is of this week's material. The course content for this week, I think, is actually pretty good if you want to go back and review it. Let me bring up your assignment real quick and see if there's anything else I need to cover to make sure you're ready for your assignment. Nope, for your assignment, it wants you to make a couple of methods, and it wants you to take some kind of input, and it wants you to give it some kind of output. So for example, one of the methods needs to convert cubic feet and returns US bushels, right? And it gives you kind of the formula there in the assignment. So for example, if I want to make a method to convert from feet to bushels, I probably want it to be private. It always needs to be static. What is it going to return? Is it going to return an integer? Is it going to return a float? Is it going to return a double? Let's say we want it to return a double. What would I name that? If the method is a conversion from cubic feet to bushels, maybe I name it cubic feet to bushels. Or maybe I name it convert cubic feet to bushels. Whatever, you just want to name it something that's representative of what it does. For the input parameter, if you want to do a conversion from one unit to another, what do you need as the input parameter? Well, if you're converting cubic feet to bushels, you need to know what's the cubic feet. Man, I'm giving you guys way more than I probably should, but It's your reward from showing up this morning. So we have a method that wants to convert cubic feet to bushels. So if I want it to do a conversion, it needs to know how much do I convert. And this is what this is. This is going to convert this cubic feet in here, do whatever math needed to convert from the cubic feet to bushels. That's for you to do. And then we want to return whatever that answer is, right? So you have a method, it returns a double. That's the name of the method. It takes one parameter, which is a double, and that's the name of it. Inside of here, we want to take that cubic feet value and we want to convert it to whatever bushels are. Look in your assignment for how you need to do that math to do the conversion. And then we want to return how many ever bushels there are. And then whenever you use it up here in your main, you want to use it. Let's say the answer is equal to convert cubic feet to bushels. And let's just say 5. Not as a string, 5. There we go. Whatever. That's how you would use it. This answer, it needs to be a double. And how do we know we need it to be a double? It's because the method tells you it's going to return to you a double. So you need to have a double variable is equal to your method. It says your method takes one parameter, which is a double, and I'm giving it one parameter that's a double. So what this should do, it should, do whatever this conversion is and give me back the bushels, and then, I can print out whatever the answer is. Answer plus bushels, or something like that. That should be well more than enough that you need to get you started on this assignment. All right. So that is all the material for this week. It does get a little bit more complicated. Making your own methods does introduce more complexity into creating your own programs, but methods are crucial to creating programs, especially as your program grows larger in size. Like I said, if you take something like a web browser, just for an example, I'm going to Google real fast. See, Chrome lines of code. If I Google Chrome lines of code, the internet tells me that Google Chrome has 6.7 million lines of code in it. Okay. And you can rest assured those are not individual lines of code just in main. They take that Google Chrome, they break it down into smaller and smaller pieces, and they take those smaller pieces and break them into smaller pieces. And they take those smaller pieces and break them into smaller pieces. On and on and on until they get to individual, very simple functionality. And then they will write the code for that individual simple functionality, and then they will start piecing it all back together. So, and that's what a method is. It's an individual, single, smaller piece of functionality. So that's why methods are extremely crucial, is breaking things down into smaller steps that you can actually accomplish. All right, so I am now standing by for any questions that you may have. All right, no questions heard. So we'll go ahead and wrap it up. As always, this video will get posted online a little bit later today. And everyone have a good rest of your weekend. Email me if you have any questions or issues.